Welcome, everyone. Thank you for joining us today for our virtual meetup titled Making It to Production with Machine Learning. As enterprises make their own AI, a new set of challenges have emerged, maintaining reproducibility, traceability, and verifiability of machine learning models, as well as recording experiments, tracking insights, and reproducing results are key. In this virtual meetup, we will learn how H2O can assist with operationalizing, scaling, and managing production deployments. My name is Saurabh Kumar, and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers for the day. James Orton is a data scientist based in Melbourne, Australia. He has over a decade of experience in analytics and data science across a number of industries. He has managed data science teams and large-scale projects before more recently launching his own startup. Chetan is also a customer data scientist based in Melbourne, Australia. He's a techie at heart, passionate about solving problems using data science, and enjoys architecting AI-based solutions. He has a master's in computer science from the National University of Singapore. Without further delay, I'd now like to hand it over to James.
Awesome, thank you, SK. Thanks for that introduction. So hello, everybody. I'm pleased to be here again for another virtual meetup with you all. My name is James, as SK mentioned. And we have our new hire, Chetan, here joining us too today. So I'm very excited about that. And welcome to the team, Chetan. Chetan, like me, is based in Melbourne and working across customers in Australia and New Zealand. So this is what I'd like to share with you today. We're going to spend most of the time talking about some of the challenges that we see around getting machine learning into production and maintaining it in production, as well as kind of introducing this concept of model ops. We're also going to touch on some of our H2O solutions in these areas and how they may help you. And then we'll give time as well for many of your questions towards the end of the session. We'll try and keep this as interactive as possible, even given that we're not physically connected at this point in time. We still would, value your feedback and questions as we go forward. So, making it to production with machine learning, what does that really mean? Well, there are many challenges, I think, along the way to a successful machine learning problem. And like summiting a mountain in the picture you can see there on the right-hand side, it's unlikely to be an easy, straightforward journey. For those data scientists on the call today, I'm sure you've experienced many challenges along the way. Chetan, can you give us some examples of some of the challenges that you faced or seen from kind of your work?
Oh yeah, absolutely. And thanks for the welcome earlier. So I guess some of these challenges that I've faced would be similar to what most of us would have faced. But broadly speaking, I think I would categorize these into two categories. One is the technical and the other one being non-technical, right? So with the non-technical bits, it's what I find is also interesting, right, to see that it's very important to set the right expectations with the business teams whom we're working with, right? So quite often they're not really familiar with how this whole AI lifecycle is all about, right? So it's very important to emphasize that the model development process is iterative, and even that the first iteration would perhaps take the most amount of time. And because, as we all know, we spend a lot of time in just assessing the data, making sure it's consumable to build a model. As some would say, data cleaning takes the largest amount of time, right? And within that data cleaning phase, it's like essentially 60% hard labor and 40% just dealing with our own frustration with the data, right? So I've been in situations where I've taken half the time allotted for the work to come with the first version of the model, right? And obviously the subsequent versions would take a lot less time while we keep driving up the accuracy. So, but when it comes to conveying this to the business or the non-tech audience within your teams or organizations, the skill that becomes more critical is the storytelling bit, right? So data scientists and our technologists in general can't say that communications or articulating it right or presentation and storytelling is not a technical skill, and therefore we don't want to spend too much time on that. But on the contrary, that becomes one of our most useful skill in our careers. So going to the technical aspects there, obviously there's a whole bunch of constraints we always work under, right? Sometimes it's time, sometimes it's money, sometimes it's availability of compute resources. So we end up making a lot of assumptions on data. We invest so much of our time in building a model, but it's important to know that the model build is only one part of the whole puzzle, right? So there's a lot of work that goes in operationalizing the models, integrating with what we've done as data scientists with adjacent tech so that business users can actually benefit from the models, right? Ensuring the models are easy to maintain, easy to refresh, ensuring models are explainable, and obviously, I think off late there's been a lot of emphasis on the ethical implications of doing machine learning. So if the models have a direct impact on the society, we need to ensure we include the right people with diverse backgrounds, such as people with from sociology or humanities or applied ethics to be part of this whole model building exercise, right? And it's also important to ensure, while accuracy is important, but outcomes quite often trump accuracy. So they do matter as well. So it's important to convey the importance of the right model performance metrics. And it's even simple things like, what's the cost of an incorrect prediction, right? Will a model, because of its incorrect prediction, will it end up resulting in somebody not deserving a job, right? Or will it end up resulting in a patient being incorrectly diagnosed with a disease? Or will we end up in sending debt collectors chasing the wrong person and recovering the money, right? And within Australia, we all know what happened at Robodeck, correct? So those are things that we'll have to keep in mind before we start on this journey of AI or machine learning.
That's
James,
awesome. Thanks. Yeah, thank you, Chetan, for your insight. That's very interesting. I think we can all agree there's many challenges kind of across the machine learning lifecycle. From identifying the right use case, challenges around the data, as you mentioned, Chetan, the model development process, the non-technical, the softer skills, kind of the list goes on. Many challenges that we need to address. But I think, as we work with organizations across Australia and New Zealand, we're seeing many arising to these challenges. Our maturity in machine learning in the region has come on kind of leaps and bounds in the last few years. And that is really great to see. And I think one of the final frontiers, if you like, or major challenges that we're seeing kind of in the marketplace now is, how do we successfully deploy and maintain models in deployment? You've probably all heard the cliche, a data scientist or machine learning is only valuable when it reaches production. And can you say that your machine learning projects are truly augmenting decision-making for your organization today? These could be kind of a number of different things. As Chetan mentioned a few examples just previously, things like understanding credit risk, likelihood of customers to churn, identifying fraud, understanding the likelihood of readmission for discharged patients in kind of a healthcare setting, or really any other use case across any other industry. The options are endless in terms of what that machine learning model might be doing in a production scenario. But really, machine learning is only valuable to your CEO when rubber hits the road, right? That's when they really care. So as we go forward, we're going to explore some of the challenges that we see specifically in this area. And I'm hoping that wherever you are on your data science journey, be it new to the field or very, very experienced, you'll get something out of this webinar. At times we might get a little bit technical, but please, don't be put off. We'll try and always bring the focus back to what this means for your business and how it might help you gain competitive edge in the field of machine learning and artificial intelligence. Oops, let me just skip on. So this is kind of a simplistic view of the machine learning lifecycle, but it helps me frame the discussion that we're going to have today. As we work through a machine learning project, typically we might end up jumping forwards and backwards, with each part being critical to the success of the problem. So just as we kind of explore this a little bit, to kind of set the scene, hopefully we'll start with define, having a really clear focus, use case, communicated and agreed with the right stakeholders, some of the softer skills that Chetan sort of alluded to earlier. Then we might move to the data phase, and we all know about the challenges here in data, and we've probably all heard the stats, like 80% of a project is data cleaning. And that may be true if you've never tried deploying and managing a model in production at scale, because there's also challenges, in many other components of this lifecycle too. Then we move through to build. How do we build models with the most predictive power in the most time efficient way? How do we do all that great feature engineering, algorithm selection, hyperparameter tuning, etc. Hopefully we'll use some automation here, perhaps tools like our open source AutoML or driverless AI could be valuable in this process. Before we move to kind of finalize, once we have a well-performing model, how do we ensure we have good documentation, the appropriate explanations around what our model is doing? How do we ensure that we have a portable kind of high frequency, low latency deployment artifact? This is something that H2O has always done well, from our open source through to driverless AI. If you're familiar with our products, you'll know about our MOJOs and Python scoring artifacts. And then lastly, execute, actually putting those models into production, be that batch or real time at the edge on a REST server, in a Spark environment, in a third-party tool, maybe Snowflake, Pega, UiPath, or really anything else, and managing their lifecycle once they are in that production phase. And as we mentioned, at the beginning, there's likely to be a lot of backtracking as we go through this cycle. We might get to data and realize that our problem statement needs to be modified or further worked on. We might get to finalize and find some bias, within our machine learning model that means we need to go back to the data stage and do some further work. And the list goes on, right? You probably, if you're a data scientist and you've been through this, types of projects, you'll be very familiar with the kind of iterative nature this process can be. However, we see the speed at which we can move through this cycle successfully is what will set us apart. And we'll dig into that a bit more as we go forward. So, I like to sort of take maybe a step back and, at this point, and try and think about some of the bottlenecks that we've seen kind of in the domain of data science, but framed in that kind of relatively simplistic life cycle that we just looked at. So if you think back a few years, many of the challenges were around how do you handle big data? Traditional data warehouses, perhaps, we're not up to the job in many cases, and there was a lot of innovation in this space. But now, the term big data is kind of, it's kind of dead. Just check Google Trends for big data. Now it's kind of all just data. We've sort of come to that challenge, and to some extent we've kind of overcome it, right? Most organizations have moved past this as a blocker for data science. The next challenge for many, was in terms of building. So should we use R or Python? How do we manage packages? How do we acquire and retain good data science talent? What models should we use, and how would we optimize the parameters appropriately? What features should we use? How should they be transformed? How do we get models built and out of the lab? Many challenges here, but many of the organizations that we work with in Australia and New Zealand are rising to these challenges and sort of breaking down that barrier. And now, so sort of kind of alluded to already, many of the kind of final challenges are in that finalize and execute phase. How do we deploy and manage these models successfully in production? And ultimately, maybe in the next few years to come, we want to make this whole process as frictionless as possible across all phases, so we can iterate faster and ultimately make it to production efficiently. So, although we could spend a lot of time talking about the other stages, and there's many webinars, from H2O, you can check back and dig into some of the content that we have, talking about some of these other kind of phases of the life cycle. But as I mentioned, we've seen that many organizations are kind of meeting those challenges there. But I do encourage you to check back to our website for materials on these kind of phases, of the machine learning life cycle. Today's focus, though, is going to be very much on the end of finalize, i.e. those deployment artifacts that we talked about, and then kind of mostly on how we execute. How do we make it to production with machine learning? So, what are the barriers here? What are the challenges that we're really sort of talking about? Well, there's a few kind of questions that spring to mind. How do we deploy? How do we monitor models in production? How do we know when models in production need maintenance? And how do we apply the appropriate governance to this entire process? As we go forward, we'll explore these, and hopefully, with looking at some of our solutions, we'll try and break down some of these barriers too. So I wanted to pause here for a minute. Perhaps it's not surprising to the audience, but many projects don't make it to production. There's a survey here, and you can see that kind of quote on the screen. I've got the link at the bottom there. It says that 15% of companies surveyed have deployed AI broadly into production. So that's a kind of a frightening stat. Gartner, have a kind of a similar, slightly less kind of fatalist stat, which suggests about half of projects don't make it to production. Either way, there's clearly kind of a problem here that needs to be addressed. And there are a number of reasons we think that kind of underlie this, as kind of a problem within our field. Production, well, what does that mean? Well, usually it means machine learning moving from the data scientists to kind of the DevOps, IT, or software engineering teams. From the outside in, it might look like what a data scientist does and what IT do are very similar, but they're not. The mindset is very different, right? The competencies are very different. Data scientists, tend to be creative and experimental. Typically, they may not like process, and they're focused on building the best possible model, kind of usually measured by some kind of machine learning metric. And they'll use whatever tool or technology they need to get there. So that might be R or Python, or it might be Julia or Scala or something else. Who knows? Data scientists like to make things work, to make sure IT systems are available 24/7. They need to make sure things conform to standards and processes. They're accountable for those systems that are making decisions. And they may only be willing to use what they consider production grade languages, such as Java or C++. I've seen many cases where algorithms are kind of rewritten from, say, Python to Java. And this takes a lot of work and, may not be a good idea for kind of a number of reasons, let alone kind of the effort involved. Often these teams are working to different goals and KPIs. And as we probably all know, they both have very limited resources. Something is needed to fill the gap, to bring harmony to this process and to these, to these teams that are ultimately striving for the same goal. But beneath that, there's many complexities. Chetan, what's kind of your experience here?
Right. Yeah, I think here there are a whole number of factors that come into play here, right? So, and also I think it's important to understand with an organization, there are far too many moving parts. So even things like, the questions that we need to ask is, do we have the right technology to be able to deploy models right away? Do we have the skills to do that? If not, what's the path for training? Can we upskill our existing engineers to do that? And more importantly, what additional governance do we need to bring in before we actually deploy a model, right? So now, I've worked with small organizations as well, small companies and large enterprises as well. So if you're talking about, let's take a case of a small company, for example, somebody who sells designer t-shirts online, right? So the requirements for them to be able to ship models faster with probably even low governance would be okay, right? Because they're obviously selling t-shirts. So worst case, what could happen here in terms of model predictions is that you might end up recommending an incorrect t-shirt to somebody, right? So that's fine. But if you're talking to, let's say, large banks or hospitals or anybody in the healthcare space, these are industries which are highly regulated. They obviously be under a lot more scrutiny. For example, the best example for us is think royal commissions, right? That's been happening here. So right now, I think aged care is done. The energy sector is next. So therefore, what's happening is a lot of teams are, kind of nervous sometimes to be able to take the right decisions at the right time, right? So they would rather think, let's be. It's okay to be at low risk. It's okay if we delay decision making. It's okay if we end up not productionizing the model, because that's the environment they're kind of working under, right? So ownership is a big problem, like as mentioned in the slide as well. Accountability is a big problem, and so they would rather maintain status quo than moving the needle on the innovation curve. So I've seen cases where the models are validated, but not really deployed on a server, so to say, right? So or the company's analytics platform, maybe because it's the standard that the company is defining is probably that saying that we have to move to Python, but all the models are probably written in Scala or R or some other language, right? And what's common also is that a lot of people have very well models, developed, validated as well, but it never makes it to the server. So it, in some sense, it's not production grade, but the models are actually being used, right? So what happens is, so they get, for if you have to get some results for every week or every day on certain number of observations for or some data, they usually get a mail with an Excel sheet, right? And what they do is they download the Excel sheet, do some data prep, and then run the models on their desktops or on their laptops, and then ship the results back, correct? So, and if you look at any, I'm talking about in the last few months, right? If you look at any large organizations, and you hear all these words like digital transformation, they're setting up a new analytics platform and all that, and if you really count the number of models that are actually under production or deployed, there would be just a handful, right, for that platform. But it also doesn't mean that those are the only models under production. So we'll have to be careful on how we define what's being under production and what's not. So there are definitely a lot of models which are being used in some way, but a lot less models which are actually deployed on a modern enterprise grade architecture server and so on and so forth. So the other reason I see, yeah, sorry, one last thing was
yeah, you go.
Yeah, resistance to change, right? So that's one big reason I see. So a lot of people are kind of happy with what works. They don't want to really break things. That might work in the short run, but obviously that's it also means that when their competitors actually move forward in the innovation curve, they tend to start lagging.
Yeah, definitely. No, I just sorry to interrupt you there, Jason, but I was just really interested in your point about, what is production? What does production mean? Because I think it means different things to different organizations, and then different things to different teams within organizations. So sometimes with these stats, they're very they make a good headline. They're quite sort of scary in a way, but it's difficult to know. I guess, as a data scientist and statistician, you're always kind of maybe a bit critical of these kind of headlines, but it's kind of hard to know underneath what the reality is. But I think there's definitely a problem. But you're right, what is production? Like, it might mean different things in different scenarios. So yeah, interesting. It's more of a scale rather than a kind of a binary outcome, right? For is something in production or is it not in production? So it's a kind of an interesting point. We could probably debate that for a while, but we'll move on in the interest of we've got an hour here, and I want to get through a bit more content for the audience and perhaps show them some stuff too. So that's good. Let's move forward. Okay, so I just wanted to give a bit more perspective as well. So you can see the link to a paper down there, at the bottom of the screen. And the diagram within this paper kind of really resonated with a number of people across the industry, including me. And why? Well, that's because much of the focus has been on machine learning, and sure, there's plenty of good stuff here. But in a deployment scenario, the ML code is a small part of a much bigger ecosystem. So you can see there, we've got a tiny little ML code at the middle, and then all of the parts that kind of exist around it. And it might be different in your case, it might be different components, but typically there's a lot that goes around just kind of the ML component. And in the paper, they talk about this extensively and some of the other challenges in terms of how we work in a deployment scenario, in terms of the data pipelines, many things to consider. But really, the question is about the potential for massive ongoing maintenance costs in real world ML systems, right? The technical debt there is real. For AI for wins in AI in production, they really are not going to come for free. So, be mindful of this when you enter into a project, that there's much to consider potentially in your production scenario. So I would recommend seeking out a paper and having a read. So what do we see, when we look at success today? So I think we've sort of touched on this a bit already, but, it's different for different organizations, but there's some kind of common themes that we see emerging. Many cases, it's the data scientists trying to throw the model over the wall to IT, and hence the picture of the wall right there. We see a lot of that in various forms. It's a big effort from everyone though, right? The use case really has to stack up. We see brittle data sciencey code, and I can say that as a data scientist who writes brittle code regularly. And then on the other side, you might have kind of inadequate or inappropriate monitoring. typical kind of IT style monitoring focused on things like availability, without considering kind of the nuances of the underlying AI or ML components. For example, how's the model performing? Is it performing as we expected? Has the data drifted? Number of things there that we'll kind of unpack later as we go through. And what you're left with is the data scientists can never really get out of the production loop. I think similar to what you sort of alluded to there kind of earlier, Chetan. And they never get out of that production loop. They can never go back and focus on new use cases. Their code continues to break and they continue to kind of put a band-aid on it, but there's no opportunity for them to go back and kind of add real value and move on to perhaps, what's the next use case that's useful for the business. And ultimately what you can end up with is senior leaders in the organization who are somewhat underwhelmed by the initial promise of AI and ML and then the reality of what it's kind of providing back to them. And all of this is kind of based on insight and what we hear in the field. Many organizations are facing these challenges, and we need a solution to address them if we're to really materialize this value that we've talked about that kind of exists within an ML project. And this leads us to model ops or ML ops or model management. We'll refer to it as model ops going forward. And really this is kind of, it's about technology, but it's also about practices, right? It's about fostering collaboration and facilitating scale. It's about letting a data scientist do data science and your IT people do the IT. The critical component here is how we bring those data science and DevOps or IT teams together in harmony. As with many kind of operational challenges, the biggest hurdles can be working together to aligned goals and cultivating those collaborative cultures that are needed to be successful in this area. So we're going to break down this concept of model ops now, and we'll look at kind of 3 core components that we see that exist within model ops. So the first one, production model deployment. Secondly, we'll move on to look at model lifecycle management, and then we'll look at production governance. So let's start and let's look at production model deployment. So what are the things we need to think about in this phase? Well, firstly, do you have production ready model at the end of your training period? So your data scientist has been through some long, potentially hugely iterative process, getting data ready, building models, and they come up, they end up with something that they're happy with. What is then the process to push that, get an artifact out of that to push that into production? That's the first thing we need to think about. And then secondly, we need to consider our production pipelines, including the data component. What's that going to look like in a production scenario? Potentially, will containerization play a part in this strategy, particularly if you're managing lots of packages from some sort of open source solution? This may help. And what is your production environment? Where's it going to be, and what is it going to do? Is it real time? Is it batch? What's happening? And what's the environment that you're going to use? There's 3 sort of rules that we use to guide us in this area. Firstly, use technology to help. Be that open source or enterprise tools. Look for something that can help you scale, or some things that can help you scale. Perhaps Kubernetes is worth considering. Some benefits might be, the ability to scale up and scale down as demand for your machine learning fluctuates. Make sure ML is immediately available to deployment. And this is again where our model artifacts like our MOJOs can be very useful. And H2O has kind of excelled in this area for a very long time. As we go forward, and later on, we'll get to have a look at some of these in action, so you can get a real sense of what we mean by a MOJO and what we mean by a deployment artifact and how it can help you. And of course, thirdly, allowing for multiple environments to facilitate moving models from the lab to the front line seamlessly without causing any pain to that production process. Next, we're going to talk about the model lifecycle management. So the hard truth, that we haven't really discussed yet in any depth is that all models will degrade over time. At some point, they'll become less useful and the decisions they make less accurate. And at some point, they may even become dangerous. Dangerous in terms of the outcomes that they're making on people, particularly, and we've sort of touched on that as kind of a theme already, or dangerous from from a business perspective, from a regulation standpoint, or perhaps from a profit standpoint. So there's lots to look out for here, and we need to have a way to handle all of these components. So, what are some things to think about, as we go through this kind of monitoring process? Well, some of the things we need to consider is, how do we look for data drift? How do we know what the appropriate model metrics we should monitor in production? How do we monitor our pipeline health? Jason, do you have any thoughts about AI ethics in production?
Right. Oh, yeah. So this is, yeah, AI ethics is such an important and complex topic. I think we probably need a webinar on its own just for this topic. The first and most important thing is to understand that, tech and tools and platform alone is not going to solve the problems associated with models causing societal harm, right? So we can't fix ethical problems only with AI or technology. We can't completely fix, for example, if there are bias in data sets, we can't completely fix that with technology. But what we can do is, to a certain extent, we can understand, minimize the harms, maybe to a certain extent, again, detect biases, and then may probably fix that, right? So to be more ethically aligned, we need to embed ethics right from step zero. Start with the hard questions. Why do we need to build a machine learning model? How was the data collected, right? Were humans involved in data acquisition? Do you think they've actually paid the right wages in doing so? Can the models be more transparent? Can we explain the model behavior to end users and regulators? Can we incorporate the concepts of, for example, data sheets for data or model cards? And more importantly, right before we hit the deploy button, we need to stop and then ensure these results are examined, not just by data scientists or by domain experts, but also we have to include the subject matter experts. And if these models are touching, people's lives, we definitely have to include people with background in, sociology or humanities or applied ethics, right? Applied ethics. So they are the ones who are better. We can understand all these. We can probably understand the harms caused, but they are the experts who can understand, who will be able to guide us, saying that, yeah, I think this is what we need to do, or these are the guidelines or guardrails that we would have to include in the whole pipeline. And however dry and theoretical it may sound, it's important to agree upon some of the AI and ethics principles and figure out how our models are faring against these principles, right? Which of these principles are we violating? Is it okay to violate? Because some of the models might be low risk, really, right? And we don't have to really reinvent the wheel here. We can reuse the work done by IEEE or within Australia Data 61, or refer to the guidance provided by the, for example, the Australian Human Rights Commission on AI governance, right? So I can actually go on and on, but I think what I'll probably pause with or stop with this quote. So this is one from Safiya Noble from her book, Algorithms of Oppression. It's highly recommend. If you're interested in this topic, you should go read that. So we have to ask, what is lost, who is harmed, and what should be forgotten with the embrace of AI and decision making?
Great, thank you, Jason. That was really good to hear your thoughts on that. I also am very interested in AI ethics and responsible AI, and I think we do a fantastic job here at H2O in that field. And there's many webinars. If you want to go deeper, we've got many kind of webinars and materials on our website to go into this. I guess the tragedy is, Jason and I have been working together now for several weeks, and we're based in Melbourne, so we haven't been able to meet up. But hopefully soon we can get together for a coffee and have a long chat about AI ethics and how our views on that, some of our favorite reads. That's a great book recommendation. There's kind of many others that I'm interested in too. So we should definitely catch up and discuss that more. And you mentioned governance as well. We'll get to that in kind of more depth as well as we go forward. Let's definitely dig into that, some of the governance components. But just to kind of finish off, I guess, on this kind of model lifecycle management. What else do we need to do? Well, we might need to establish and customize alerts, because as we scale, as hopefully we get multiple models in production, we won't be able to look at everything. We need to manage schedules and triggers, based on probably certain thresholds that make sense for the business. We need to think about retraining and updating models and how that process is going to work. We need to handle different versions of the models, right? And then you need to roll back if a model is not performing as expected. And we need to think about how we fail gracefully, right? Because we know that our models will fail in production, and we need to maintain the user experience here, be that kind of an internal user or an external user. You know, if your model is customer facing and doing something really critical for your business, you don't want it to suddenly go offline for, you know, even minutes, and definitely not hours or days, as it may happen, you know, if you have no fallback procedure and you need to start from scratch and retrain a new model. So you need some kind of, you know, you need some kind of failover, some kind of fallback, be it a simpler model or some rules. There needs to be some consideration of that process. And then finally, you know, how do we kind of A/B test models in production? How do we make sure that any new model that we've built, maybe we built a new model because our model has drifted, or maybe we built a new model because we think, you know, we've got new data and new insights that might provide more signal to this problem. But either way, how do we know that that new model is going to perform better than the old model? And how do we manage that into a production process seamlessly? So much to consider here in terms of the model lifecycle management, many moving parts. And because of those many moving parts, and Jason, so you know, you touched on this already, but production governance is a very, very important part of this whole process. And let's go into that and kind of address that a bit more now. There's a number of things we need to consider in this governance kind of framework. What is the data and model lineage, you know, within this production environment? How do we introduce traceability and version control? How do we manage audit trails? Who did what and when? And access controls. You know, we need to ensure that the intern doesn't delete the mission critical models in production, right? That's a kind of crude example, but there's many, you know, obviously there's much to this that needs to be managed, particularly when you're building models at scale for critical business decisions. And, you know, governance is perhaps not the first thing we think of when we, you know, imagining cutting edge machine learning, deep learning algorithms, and all that really fun stuff, but it's got to be one of the most important, right? Imagine your model is making critical decisions for your business or about your customers. How do you justify these decisions and the data and models used at a given point in time? Governance is absolutely key here. So hopefully that's given you some ideas about how to implement model ops in your organization. Some of the challenges, but you know, hopefully we've balanced kind of the negative with the positive to get you guys kind of, you know, fired up and pumped up to build, you know, to really implement ML within your organization to kind of drive value. And at H2O, we've got products, you know, kind of existing across that machine learning lifecycle. And we don't have time now within the next 20 minutes to go into each and every one. So like before, when we talked about kind of the theory, we're going to focus very much on the end of the pipeline, specifically for making it to production. And we'll look at two of our products here. Firstly, we'll look at driverless AI and how it can really help in that finalized phase, the model deployment artifacts that we've talked about. And we're also going to talk about and have a look at model ops, which is our new product, you know, squarely in the model ops space, developed based upon feedback from our customers who are facing these challenges at the forefront of machine learning at scale today. So with that, we'll take a quick look. So firstly, we're going to look at driverless AI. And there's a lot to this product, and I encourage you to go back and revisit other meetups and webinars on our capability here. Even if you've seen this previously, we've just released a new version of driverless AI 1.9, some really fantastic and exciting new features. Within the new version, there's a blog post and webinars related to that, and much, you know, a lot of content in terms of how driverless AI works and what it does across different industries, scenarios, and different components of the tool. So be that the responsible AI components or the automation, I thoroughly encourage you to go back and deep dive into driverless AI and everything that it can do for you as an organization. But today, we're just focused on the deployment perspective. We're not building any models today, we're just pushing them into production. So what does that mean? So we get this kind of handy automatic scoring pipeline that we've talked about, you know, including the transformations that might have happened in that process, plus the modeling components. And those scoring pipelines that we get out of driverless AI are very, very flexible, across a number of languages. So be that Java, C++, or Python, or with R and Python wrappers too on top of the C++ MOJOs. And as well as having those artifacts, we can integrate with a number of other platforms, some of which you can see on the screen here, but there are many, many others. So very flexible, high frequency, low latency deployment artifacts. We see our customers using these and getting great value from them. So I wanted to pause and go a bit deeper now, really just on the MOJO itself and how powerful this can be. And we're going to use it now. We're going to see the MOJO and we're going to use it in a number of different scenarios, just to give you a taste of how it can be used. And remember, there's many, many ways that you could use this. We're just scratching the surface, really. Remember also, this isn't just the model. It could be an ensemble of models plus extensive feature engineering. Those pictures on the screen might be a bit small, so I do apologize. But here you can see some fairly complex stacked ensemble that we've got for predicting some binary outcome for bad loans. And you've got a number of kind of input features there towards the left-hand side that have been transformed in various ways for different components of that ensemble. So a lot of complexity under the hood, just sitting within that MOJO itself. So let me just quickly show you the MOJO within driverless AI, and then we'll jump back to the slides to give you a bit more sense. So here we've got a couple of completed experiments, and let's have a look at one of these. And we're looking at this currently through the GUI, but imagine that we could be looking at this through our R or Python notebooks as well. So here you can see immediate download. So we can download from here that MOJO scoring pipeline straight away, and then we're going to get. So we can imagine this experiment that we're looking at on the screen here is completed. We're happy with this. We've done everything that we needed to do around data, around the model building. We've looked at it from a kind of interpretability standpoint. We're happy with this model and we want to deploy it. Then we click this button and we download the MOJO. So very, very simple. And then what we're going to do is we're going to take that MOJO and use it in a couple of scenarios to kind of bring this to life for you guys. Let's go back to the slides for a minute. So at H2O, we talk a lot about using Python with driverless AI, and we've got some, really fantastic integration with Python and different ways you can use Python within driverless AI through custom recipes and the Python client. I encourage you, if you're a Python user, to explore these, and I'm sure you'll see lots of benefits there. But we also have a powerful R client integration too, and we know from our experience in the region, in Australia and New Zealand, that R is particularly popular for machine learning. So today I wanted to show you some of that capability. And again, there's much you can do with R and driverless AI. So please reach out to me or have a look for our extensive documentation for other ways you can use R to drive driverless AI or do other components of the kind of the workflow. But in this case, again, we're going to be super laser focused on the scoring component, given the time we've got, and we also want to make sure we've got time for questions at the end. So what I wanted to do is show you using the MOJO within RStudio. So let's just bring that up for a second. So here you can see kind of a very simple bit of code we've got here to use to do some scoring using the MOJO straight out of RStudio. So we're loading a couple of packages here and the driverless AI license here. Then we're going to bring in the MOJO. So that artifact that we just downloaded from the GUI of driverless AI looks like this. So this MOJO pipeline here. And within there, you can see we have the MOJO itself. We also have a little example CSV, which we can use to demonstrate the scoring capabilities. So the next step that we've done is we've loaded up that example file. What we might do is just have a look at this to give you guys a sense of what this is. MOJO within R. But imagine the rest of your R code surrounding this. Maybe you do some data prep. Sorry, I think I might be having some internet difficulties. Hopefully you guys can still hear me. Maybe you do your data prep around it, or you're using R Shiny as the output to visualize some of the components of your MOJO. You know, the options are endless. Leverage that to your will and delight within the kind of the R environment. And we'll come back to the slides just quickly and talk about using the MOJO in another scenario. So you can also do it within tools like Snowflake. So if your company is using Snowflake already, this could be very powerful for you. And again, you know, if you're interested in the integration with Snowflake, there's a lot of capability here, and I encourage you to seek the information out on this capability. There's a webinar that we've done in conjunction with Snowflake, which takes you, into the detail of this deep integration that we have here. But for this purpose, again, we're just going to look at scoring. So using the external function within Snowflake, and then scoring natively within our SQL environment. So let's take a look. So we've got a worksheet over here. So again, the same data set. So you can see I've just run my select 30 on this data here, and it's this similar kind of data about loans, and we're going to use the MOJO here again. So natively from our SQL environment, just to do some scoring. So imagine kind of the power here, for your SQL user. You don't have to leave your SQL environment, and you can use your SQL syntax to score your data, and you can then take that scored data and use it within your Snowflake environment. So whatever the kind of the next steps might be, imagine your kind of deployment scenario built up around this Snowflake integration. We've shown this to a number of customers and prospects in the region who've been very excited by this capability, and we hope you guys are too on the phone. I encourage you, if you want to see more in terms of that Snowflake integration, please seek out the webinar or reach out to me, and we can give you guys kind of a more in-depth demo in terms of the capabilities that we have there. So hopefully that's given you a good sense of some of the deployment options. But none of these have addressed the monitoring and governance requirements that we discussed earlier. So maybe you want to build your own or use another solution here, and that's absolutely kind of possible with our H2O products. But I also wanted to show you our solution here, which is called H2O MLOps. And again, we're going to be leveraging the MOJO here and working on Kubernetes. MLOps closely integrates with driverless AI, and we'll show you that to you now. So let's step back again, and let's look at MLOps itself. So here's MLOps. What we're going to do is add a new project. So imagine MLOps is integrated into driverless AI through model storage, which can be leveraged through this project section. So now we've got a new project here. If we go back to our instance of driverless AI as well, now we've got a new project here called webinar. So very apologize for the unimaginative name, but hopefully this is enough to give you a flavor. And we can link kind of one of our completed experiments here to the project. And now if we go back to MLOps, what we'll see, we now have this model within this project over here for webinar. So a number of things that we can do for MLOps, for managing this process. So you can think that, again, we're talking about that process, the model development process. You push the model into the projects tabs. You reach out to your DevOps, your IT guy. Hey, the model's ready. You can share the project, and quickly it moves to this MLOps environment where we can look to move to production. So again, what can we do from here? Well, there's a number of things we can do. We can deploy to numerous environments. So let's deploy this one to dev. And you can see that will now start deploying. Also, in the style of a cooking show, here's one that I did earlier. Let me show you some of the other capabilities here. And I want to make sure we've got time for questions. So I'm going to go through this slightly more quickly than we normally would. But if you're interested, please do reach out to us and we can do kind of a much more in-depth demo here. But imagine here, we've got a couple of models, one in deployment, one in dev. We can look here at events. So, this is your governance process. Think about who did what and when. We can get a good sense of that. We can also, from here, from our deployments, we can look at the monitoring. So I've got the monitoring running up here. We can look at the latency that we're seeing from our monitoring, our drift, population stability index, look at the performance of each of our variables, across the scoring data that we're seeing. So huge amount of capability that we have, linking driverless AI to our new MOJO capability. What I want to do now, we'll just quickly go back to the slides and summarize, and then we'll allow some time for some questions. So hopefully that rapid tour of making it to production with H2O was useful, and gives you some kind of insight as to how you might deal with some of the challenges here. Let's now come back and think about kind of the summary as to what this means and some of the benefits here. Hopefully through creating kind of harmonious teamwork, we'll get cost savings for your business, right? And maybe we'll get better staff retention too. So that's kind of the sort of number one benefit we might see. Also, by maintaining control of the process, we really help avoid that machine learning failure that we talked about earlier, and all the associated ramifications that might be there in terms of reputational damage, ethical or regulatory breaches. And again, we could have a whole meetup on this, and maybe we will in the future. So, lots of ideas for new meetups, and hopefully we'll get through all of those as, in the coming weeks and months. But finally, I wanted to focus on something positive. What does it really, mean? Well, it helps us achieve scale at speed with the appropriate governance, and it can really help us drive value from our machine learning projects in the ways that kind of have always been promised from machine learning. Thank you, guys. Hopefully that was useful. What I will do now is hand back to SK, and we'll take some of your questions.
Thank you, James. Thank you, Chetan, for doing a wonderful presentation. We have a lot of questions in the chat window. Let's try to get some of them with the time we have at hand. What are the common issues with deploying machine learning models, and how does H2O.ai help solve them?
Okay, maybe I can take that one. So I think the challenges are some of what we've laid out kind of in this webinar. But really, the first challenge that you're going to face is moving from that training phase to deployment. So you've trained a model that that works in a training scenario, but how does it work in a deployment scenario? What are the package dependencies? What do you really need to get from training to deployment? That's the first major hurdle. So address that, try and overcome that first. Then the next one is really, how do you monitor it? Now, it depends, right? Depending on how critical your use case is, the monitoring might be slightly later on, but there's always going to be a need for some level of monitoring. So that's going to be the next major challenge. And then the third one, kind of as we talked about, in that example, is the governance. And again, depending on what your use case is and what its kind of real impact is, it might be less governance or more governance, but there's always going to be a component of governance required.
Thank you, James. What is the pipeline for creating a production machine learning based algorithm?
Right, okay, so let me take that. So the pipeline here, I think, so let's say for your model training and development phase or cycle, you would have slightly different pipeline wherein obviously start with your data prep and then feature engineering. And so while we think of all these steps within your ML lifecycle, it's important to ensure you have certain design principles and architecture principles in mind. So which means that at every stage it'll be good to have, for the sake of reproducibility as well, it'll be good to have, for example, features once engineered to kind of persist that if possible. And then when you start training your model within the pipeline, we should be able to if you have to rerun the whole pipeline again of data prep, feature engineer, model build, you should be able to do that as easily as possible, right? But once you are done with your validation and test and everything, when it comes to deployment and scoring, so that's a different mechanism of pipeline you might have. So like James showed in the demo today, so that will be a one wherein it should be the pipeline would consist of basically your model binaries, and whatever transformation that you might have done in the model build cycle to include them as well. And so depending on how you want to score them, right? So it could be if you want batch scoring, Snowflake was a good example which James showed. If you want, you can have your REST API rolled around your model predictions as well. And the other thing is that of late there's been a huge interest in streaming data, right? So how do you integrate your model scoring pipeline with your streaming infrastructure, like something like Kafka, for example, right? So the more extensible your framework is, the more easy it becomes to integrate with any of these different options that your team might need. I hope that answers the question.
Of course. Thank you, Chetan. What is the best way to scale ML model in production that can handle thousands of requests in seconds?
Okay, maybe I'll take that one. It's a difficult question to answer without knowing more about kind of the environment, or the use case and the data. But scale, this can be a challenge, right, for many organizations. Typically, you want your deployment model to be using a language which will allow you kind of that low latency, high frequency components. So Java or C++, good for that. So, again, in terms of our tech stack and what we offer from the output of driverless AI, those types of deployment artifacts can be very useful in terms of the scaling component. Then you also got to think about your environment, and there's many things to consider there. But if the person who asked the question wants to have a deeper discussion with me and Chetan on that, we can take that offline and explore more about how you do that, how you scale.
Thank you. How to manage feature pipelines, model retraining, and data drift?
Yeah, so this is a good one. So some of it I think we touched upon in the previous question I answered, but so essentially feature pipelines is, as we all know, I think feature engineering is one of the most critical steps in our ML lifecycle, right? So now we're talking about MLOps or AI ops. So what becomes more important is as part of the pipeline, so there are many design decisions that we can take, right? So we can have feature stores as a very common way of people do, wherein we want to ensure whatever features we generate, we want to persist them, version them as well, right? And the other thing is that we could also use previously built models, the outputs of those as features as well. So it depends on how you want to design the use of the feature, design the feature store and the model store as well. So both can go kind of hand in hand. And data drift and model retaining also are kind of related. So data drift would be essentially we would want to keep a track of the distribution of input data. Has it changed? Has it drifted from what has been previously trained on, right? So we have to keep that. We have to keep a tab on that. And so when we can define thresholds, and so I'm not talking about reinforcement learning here, but a very simple way of defining thresholds and saying, okay, so if the distribution has really shifted beyond a certain threshold, then I think now is the time to retrain. Now, if we have done a good job in versioning this whole pipeline, then the retraining becomes very, very simple. And obviously, there's a lot more. I'm trying to very simplify this to a great degree. It can be a lot more complicated than this, but yeah, we definitely need it. Happy to have a chat with more detailed chat on this, but to put it simply, I guess this is how we'll have to do it.
Thank you, Jason.
Yeah,
we'll one more
just
question.
To add to that too.
Go ahead.
Oh, okay. Cool,
no, go ahead, James.
No, you do one more. Yeah, I was just going to add to what Jason said to say, and we can do that kind of within our tools. So within ModelOps, right, we can monitor drift and we can set up alerts, to let us know when that passes a certain threshold. And that will be different in different scenarios, but be aware that monitoring and alerting is how you're kind of going to deal with that and come to the point of, oh, now I need to retrain.
Okay, very quickly, 30 seconds. Need help in digitization of my plant manufacturing processes through MLDL AI. Who wants to take that?
I can go for it. Yeah, I think
this is a question that could probably take half an hour.
Yeah, exactly. It's a very wide, very broad question. Yeah, it's a very broad question. So, but I think digitization, right? I'm interpreting that as a way wherein, for example, you might have, let's say, your documents which are handwritten, or you could have probably, a voice samples which have to be, transcribed and things like that. So obviously, we would need specific models for each of those problems or use cases, and then try to get into a form where we can further use that transform data by by using other ML/DL techniques for for any other downstream applications? Yeah, it's a very broad question, so I'll probably pause at this.
Sure. Thank you, Chetan, and thank you, James, for doing a great presentation. To our audience, the questions that we could not take today, we will write back to you in an email along with the slides and a copy of the recording. For now, we're at the top of the hour, so thank you for joining us, and bye-bye for now. Have a great rest of your day, afternoon, evening, wherever you are in the world.
Thank you.
Thanks, everyone.
Thanks.